Remember that chart? Not the circle, but the chart? So, you remember the chart we did? So, I just want you to focus in on cosine right now. And we're going to graph this together. Now, we're not going to graph root 3 over 2 or root 2 over 2 or even 1/2. What we're going to focus in on are the angles at the axes. So, we're going to do a table of values. The x-coordinate is going to represent the angle. So at 0 degrees, what does cosine equal? What can be a little confusing is that we're so used to saying that the x goes with cosine, now we have to think of it as a graph, as a point on a graph. So the x-coordinate is the angle, and the y-coordinate is the answer. So what's the answer? If it's 0 degrees, or radians, then what's the answer? And the answer is positive 1. The next is going to again be an angle. I'm going to do it in radians. So at pi over 2. And then the y-coordinate's the answer. What's the cosine at pi over 2? And the next one on an axis is pi. And what's the answer at pi? So as you look down here, at 0, the answer is 1. At pi over 2, the answer is 0. At pi, the answer is... Stop talking. Negative 1. At 3 pi over 2, what's the answer? 0. And then at 2 pi, that brings us back to 0, and the answer is 1. On the right, we're going to draw a set of axes, and we're going to graph this. So starting with the table of values, what does the graph of cosine look like? And we're going to plot some points. So at 0, 1, we're going to plot a point. At pi over 2 and 0. At pi, negative 1. At 3 pi over 2, 0. And at 2 pi, positive 1. It kind of looks right now like it's a V, but we need to continue the wave. It's actually going to be a wave. We're going to continue the graph to the left, following a pattern. Now, do you see a pattern here? And this is the pattern I want you to see. Top, middle, bottom, middle, top. You ready? Top, middle, bottom, middle, top. I'm going to continue that pattern to the left with negative angles. So I'm going to put in the negative angles to the left, and I'm going to continue that pattern without a table of values. Remember we went top, middle, bottom, middle, top. That pattern. To the left, can you continue that pattern? So at negative pi over 2 would be in the middle. At negative pi would be at the bottom, middle, to the top. Now it kind of looks like a W, right? So I want you to know that when you connect these points, it's going to be a wave, which means it's going to be curvy, not pointy. Curvy, not pointy. And it goes on forever to the left and right. I just chose to stop. I could go forever right and forever left and do this. That is a graph of a wave. If you've ever spoken into a device where it actually takes your sound and you can see it, that's called a sound wave. If you are ever in a submarine, which I've never been in one, and they use radar, they use waves, sine and cosine waves when you're in a submarine. If you ever were a bat and you flew around and you wanted to know where food was, you would use waves, sine and cosine. They're awesome at trigonometry, because bats that are bad at trigonometry, they die. The bats that are good at trigonometry find food and live because they can't see anything. Did you know that? So they use waves to know where things are and how close they are. Hey, you learned something. Hey, underneath. Do you know the domain of sine is forever? All real numbers. But the range, do you notice this wave has a top and a bottom? And the bottom is -1. And the top is +1. That's the domain range and what a trig wave looks like. Let's do another one. The next one we're going to do is sine. So that's cosine. What was the pattern for cosine again? Top, middle, bottom, middle, top. And it would just keep going forever with that pattern. So once you know the pattern, you would just continue it for as long as you needed to. Sine, we're going to do a table of values again. And we're going to use the same angles. 0, pi over 2, pi, 3 pi over 2, back to 2 pi. For this, we're looking for the y-coordinate at that angle. So at 0 radians, the y value is 0. At pi over 2, the y-coordinate is +1. At pi, the y-coordinate is 0. At 3 pi over 2, we're at the bottom of the circle, it's -1. And then back to the beginning again, it's 0. We're going to graph this. So, this one starts at 0, 0. Then at pi over 2, it goes up to 1. At pi, back to 0. At 3 pi over 2, it goes down to -1, and then back to 0. This pattern is middle, top, middle, bottom. Middle, top, middle, bottom. Middle, top, middle, bottom. And we're going to continue that pattern to the left. So I'm going to not do a table of values, but see the pattern and continue the pattern to the left. And again, when I connect it, it's going to be curvy. This is what's called a sine wave. Where did we start the wave for sine? And the answer is we started it in the middle. Where did I start the wave for cosine? And the answer is we started it at the top. Cosine starts at the top, sine starts in the middle, but they have the same pattern. They just start at a different point. Yay? It is the same pattern and the same picture. What picture do they make? They make a wave. What's the difference between the two? Is where they start. Sine starts in the middle. Cosine starts at the top, and they have the same pattern. and they make a wave. The domain, same thing. All real numbers. Range, same thing. It goes from -1 to +1. We're going to do one more. Tangent. Now, again, it might be helpful to look off the chart at 0 radians. What is tangent equal? Which is 0. At pi over 4, what is tangent equal? +1. At pi over 2, it is undefined. At 3 pi over 4, it is -1. And at pi, again, it's 0. That's our pattern. We're going to draw a set of axes. And then we're going to see what it looks like. So at 0, the answer is 0. At pi over 4, the answer is 1. And at pi over 2, it is undefined. When something's undefined, what do we draw on a graph? An asymptote. Tangent has asymptotes. At 3 pi over 4, it's -1. And at pi, it's 0. We're going to follow this pattern to the left and to the right and see what picture does this create. Not a wave. And the picture a tangent creates is like a cube function. It goes up to the right and down to the left. It curves up to the right and down to the left. This point in the middle is called a point of inflection, where on one side it smiles and on the other side it frowns. The domain here is all real numbers except multiples, odd multiples of pi. So every odd multiple of pi over 2, I should say, every odd multiple of pi over 2, there's going to be an asymptote, while the range is all real numbers. I want that to be your reference sheet. So tomorrow when you practice with this learning packet how to graph, sine and cosine are waves, tangent are cube function looking, right? Goes up in one direction, down the other. Tangent goes up to the right and down to the left. And we have asymptotes in between them. Completely different, something you've never ever done before. So it's going to take practice. And that's what we're going to do. All right, Mr. G Math, over and out.